All right, guys, so our first attempt here at a remote learning lesson is actually going to be a review of some of the stuff we covered just before we left. So if we look at this, one of the last chapters we hit, or units, was 7.2, solving equations using addition or subtraction. And we're going to break down each one of those words in a little bit. Just notice the word equations and addition and subtraction. This might look kind of familiar to some folks. We had set up scales to show these equations, these algebra equations. So in this instance, let's pretend that each one of these little coins is worth 1. And I could say right now, I could put together an equation to say the left side obviously equals the right. If you look here, this is kind of the balance. We'll be seeing this a little bit later. But if I put more things on one side, you see how it tips out of balance? So right now it's not equal. This is not equal to that. When I lift it up, it'll slowly work its way back to the equals area, or at least close to it. If I put an object over here, it's not equal the other way. You could say that this, you could even say in inequality, this is more than this, the greater sign. Before what we're doing, this chapter is all about equalities, or equations. So when we say an equation, we're really talking about the equals sign. Okay, can we see that? Yeah. And so as I look, I'll just say what's on the left and what's on the right, and those two things are equal. So I've got some unknown block and then 2 coins. So I'm going to call this block B. Okay, I don't know how much it is, how much it's worth. Some of you are really quick. You already see how much it's worth. But let's just work our way there. So I got a block plus 2 over here. And then on this side, I've got 1, 2, 3, 4, 5 blocks. Right? That's all we're talking about here, except we're going to eventually be using bigger and bigger numbers in both addition and subtraction. So I got to figure out what this block is equal to. And basically, I want to use this same scale to figure that out. And I can't just pick up the block, though, and move it over here. What's funny is actually you'll be able to do stuff like that later, but I can't do that yet, and I have no idea what I'm doing. So instead of trying to move the block, to figure out how much this weighs, I want to get that block by itself on one side. So I'm going to leave that block there, and I'm going to get rid of these 2 coins. But let's watch what happens when I do that, though. So one of the things you might remember from class last week, or I shouldn't say last week, several weeks ago, but for the scale here, the equal sign, we really like to make that a big deal to say, look, let's do some railroad tracks. Let's make it a big deal so we can say this side's got to add up to this side. And when I do something on one side, I have to do it on the other. And let me demonstrate that to you right now. I know I want to get this block alone so that at the end I can say, yeah, B equals what? Sorry, move that up a little bit. B equals what? Got to figure that out. So as I look over here, I'll say, well, let me just get rid of these 2 tiles, these 2 coins, and then I should be good to go. But take a look at the scale. Am I actually good to go? Like, what's wrong? I took 2 off of the left, but I didn't take 2 off of the right. That's why it's out of balance. Anytime you're working with the scale, you can put as much as you want on either side. It's just got to be the same amount. If I rewind to this where it's even, okay, I can add a block to this side, and it's out of balance. But if I add another block to this side, aren't the 2 sides equal? So it goes that way with both addition and subtraction. So I'll remove those, right? And so as I take 2 away from here, think about the math operation that would be. Minus 2. I've also got to take the same amount away from this side, 2. And notice it's still in balance. So I can add things or subtract things as long as I do the same to both sides of the equal sign. So when I come back here, think about the math we did. I had 2 blocks there, and what did I do? I took away 2. Look at what it was. It was B plus 2. Now it's take away 2. And I did that same thing over here, take away 2. Okay. What ends up happening, we had shorthand for this. This side's really cake. 5 minus 2 is going to be 3. You should still go through these motions, though. If you don't do this now, when we do the harder stuff later, or multiple operations, you will start to get it wrong. So plus 2 minus 2, I just imagine a person who takes 2 steps forward, and then he takes 2 steps back. Did he actually go anywhere? Not really. So what we always do is we could say plus 2 minus 2 gives us 0. And then we'd cancel it out and just say, hey, B is all that's left over on this side. I got B by itself. B equals 3. Really quick, I want to break down what we see here. Just all the words of this so we know, what to expect going forward. And really everything that we can encounter. Solving just means like get the answer, right? But we're going to see something neat about this as we break it down, get the answer. And then equations we know are, this is important to think about, they're the number sentences with an equal sign. So you have stuff over here and stuff over here. And then using addition or subtraction. Okay, to me, what's interesting about this, like at first it seems like a bunch of extra words, like solving equations. Like I already know how to do that, but think about it, not really. You know how to solve expressions, right? 5 plus 2, you would then tell me that equals. To solve that, you would say 7 is the solution to that. I just solved that. But is this an equation? No, that's an expression. And if you think about it, up till now, every equation you've seen, so this is an equation now, did you actually solve that? No, you didn't solve it. You just looked at it and you're like 5 plus 2 equals 7, so what? So now the only thing we can do when we say we're solving equations, it means we're replacing one of those numbers with a letter. And so you're never going to, I shouldn't say never, 5 plus n equals 7, you got to figure out what does n equal. So sometimes, I don't know why they would revert to this necessarily, but you'll see them say 5 plus 2 equals n. Is that still an equation? Yeah. Do you need to solve for n? Yeah. Is it really easy? Yeah. But now we would say this is the kind of harder style we have. 5 plus n equals 7, and then they'll ask you to solve it. They're really saying, what is n? Okay, that's really what they mean. And so now let's just really analyze and remember what were the steps. We said we were really only at 2 steps. You'd see an equation like this, an algebraic equation, and you had 2 steps to think about. The first one, and we did it in the demo with the scale, is to add railroad tracks. And really remember how cool we are. We can have multiple x's. You know, it's actually CKS, right? Tracks, but whatever. So we got to add those. So what do I mean by that? We're going to separate this equation into 2 sides. In these railroad tracks, just bring them down. Trust me, do it. It's going to make your life easier as we go forward. You got to do it. So step 1 is done, and it's really easy, right? This is why we do it on a separate sheet of paper. Second, get the variable by itself. So right now, if I had, like if this is the equation I gave you, n equals 5, do you need to do any work? No, because you already know n equals 5. There's nowhere else to go. Okay, if it was n plus 0 equals 5, that's one of our old properties, you junk that and you have it. Okay, what you're doing is you're getting n by itself at the end. This is like our target, n equals whatever. Okay, but right now it's not by itself, so I couldn't tell you what n equals. I know that n losing 23 gives me 47, but I don't know what n equals. So that's what I need to find. And how do I do that? I need to use the inverse operation. Okay, if I rewind really quickly, my scale problem, I think it was n plus 2 equals 5, right? And then what did I really do to that scale, though? Here's this. What did I do to the scale? I took 2 away from each side. Why did I decide to take 2 away? Well, if I look here, this is the math version of it. I had 2, right? So I need to do the opposite of adding 2. So the opposite, which is what the word inverse means, it's opposite. So the opposite operation of adding was subtracting, and you just do that same number. So when I do that, I get n equals 3 left over. So if I come up here, how do I get rid of a losing 23? Don't overthink it. What's the opposite of subtraction? Addition. Okay, and if I'm going to add 23 to this side, what do I need to do to this side? Got to add 23 over here as well. Okay, and I think this is harder to do with the scale. What this would be like, if I can try to pause and show you this really quick, it'd be like this. If I had this block here is normally n, and here's my scale, right? I don't know, pretend that, there we go. And this is, 47 over here. And what the best way I can think of this is if I had a block and then I like knocked off, 23 worth of it. So really this is all I had. And it's like asking you to work backwards to say, so if this part of the block that lost 23 is worth 47, what would a full n block be? Okay, don't bother trying to draw this picture. That's just to kind of help you visualize this. The addition way is way easier. N plus 2 equals 5. Like that's way easier to do, and I can't destroy my equipment. Anyways, back up here. So if I lost 23, and then I'm gonna add 23. Our shortcut is to just cross that out. It cancels out. If you feel like you need to show me that it equals 0, go ahead and do that as well, right? Because then you'll end up with n losing 0, right? Anytime you go 23 steps back, but then go 23 steps forward. Where are you? You're at 0. Okay, that's why we chose this number, is to get back to 0. And that's why we chose this operation, because it's the opposite, right? So I've got that, n minus 0, effectively it's just n over here now. That side's done. I've canceled that out. Over here, 47 plus 23, just hit that up really quick. What's 7 plus 3? 10. And then 4 plus 2, 6, one more, 7. So there really ought to be one last step here, guys. And I'll demonstrate 2 more in a second, just so you've got plenty of practice as you go forward today. I shouldn't consider myself finished if I want to be sure that I'm right. I'm getting n equals 70 as my answer. Okay, to make sure that I'm right, I should come back to that original problem. Sorry, n minus 23 equaled 47. And I should put 70 in. So 70 minus 23. And then I should ask myself, does it equal 47? If it does, I know I'm good. Like, let's say I did it and I messed something up and I got 60. Right? When I put 60 back in here, I'd get some number that's not 47. I'd get 37. I could say, wait a second, this doesn't seem right. So now, though, if I do 70 minus 23, as long as I get 47, then I was good to go. 6, 10, 10 minus 3, 7, 6 minus 2, 4. So I've double checked it. And some of you are really recognizing these different things that I'm showing you now. Okay. So I'm going to do a couple of examples really quick. What I would do if I were you is pause the video as soon as I write these out. Okay. And they're not going to be too mind-breaking. N minus 56 equals 83. I like to use that because it looks complicated. Some of you are already going to guess the wrong thing for that. Go slow and use my method, you'll be fine. And then this other one, we'll call it n plus 12 equals 12. That's a little bit trickier, but I think you'll be able to get that. So anyways, pause. See if you can use my strategy to solve these really quick. Now, I'm not really going to pause myself. That's why you should hit pause. So I'm going to keep talking. So step 1, railroad tracks. Set them up. Boom, boom. Step 2, get the letter, the variable by itself, using inverse operations. So there's nothing over here. The n is not by itself. It's got this over here. So I need to do the opposite of minus 56. What's the opposite of minus 56? Plus 56. Okay, those ones are going to cancel out, and I'll go slowly with this math over here. I've got a 9 and I've got a 13. So I should ask myself off to the side, is 139 minus 56, sorry about that, is that actually 83? 13 minus 5, it is. So we know that n equals 139, and I should present that to somebody as the final answer for that. Okay, step 1, railroad tracks. Step 2, inverse operation to get n by itself. So what's the opposite of plus 12? Minus 12. Okay, if you aren't focused, you'll say, you do plus 12, you'll double this up or something like that. You always got to do the opposite operation. So it's plus 12 and minus 12. They cancel out. 0, you know. N equals 12 minus 12, 0. Well, that's interesting. So if I put 0 back in, 0 plus 12, does that give me 12? It does. But my answer is not this double check thing. It's n equals 0. Okay. I have 1 or 2 more exceptions I'm going to show you for today, the kind of harder stuff, and how I would figure those out if you see them. These are more like next year, the year after problems, but I think they're kind of good to see now. So these are the 2 that look a little tougher to us. I'm going to start with this one on the right. Because when you look at this, you'd say, all right, railroad tracks, easy. Always do that, right? Easy step 1. And then you say, man, how am I going to get n by itself? Like, this 23 is here. It's got no operation, though. Okay? I mean, try to remember that every number that is that you don't see a sign for is actually positive. So what's the opposite of positive? You could think about it that way. What I actually, though, I like to do with these problems is use my old commutative property to just rewrite it. Nothing says I have to make progress right away. I could just make it more friendly for myself. So the commutative property means that I can switch the order of these, and it's still going to be the same thing. So n plus 23 still equals 50, right? And now from there is an easier problem to do. Yeah, what's the opposite of plus 23? Minus 23. When you do that, you should be getting 27 left over. And I bet a lot of you could have figured that out there, but we want to have a process. Just, you will see this in future years. We're going to be moving variables back and forth. Okay, and this one is going to maybe this is a little advanced. We're not going to see much like this year. And some of you can look at that and already know, like, dude, I know that's 8. Okay, but just check out this process. Why is this one harder? First railroad tracks. Because it doesn't have an operation. And if I figured it out, I could say, well, it's positive 15. What's the opposite of that? But the other thing is I can't just reverse the order. One of the things we talked about is properties of addition and multiplication only work for addition and multiplication, meaning I cannot say that 15 minus n is the same as n minus 15. That's simply not true. Okay, you're not allowed to do that. We know that if this was like 5, 15 minus 5 is not the same as 5 minus 15. So I can't do that. Okay, so one thing that I've seen people do, and I kind of like this, is where you'll say, well, I have an operation and I have my letter. Am I allowed to maybe move my letter to the other side and then come backwards? Okay, so let's just check it out. This is like one of the harder ones I gave you right before the break. So let me do that. I'm going to actually add n to both sides. Okay, and just go slow with it. So what would happen to these ones? Subtract n, add n. Well, those are going to cancel out. So what I've done is I just got 15 by itself on this side. And then what am I left with over here? I'm left with 7 plus n. And I just showed you, I don't really like that order, but now I have n plus 7. Right? I just reversed the order. Okay? If you're not sure how I got there, kind of rewind, check it out. You can message me too. So now I've got 15 equals n plus 7. Remember, I'm trying to get the n by itself. Is it okay if the n ends up over here? Yeah, because isn't this n equals 2 the same as 2 equals n? Yeah, those are the same thing. So what I'll do now is how do I get this n by itself? Right now it's with a plus 7. So what do I need to do? Minus 7. When I do that, those are gone. 15 minus 7 is 8. So I have 8 equals n, or n equals 8. Okay, if I put it back in, sure enough, I'll get that 15 minus 8 is 7, and so I've been checked. Okay, guys, if you have questions still as you go through this assignment today, check out the other video. Sometimes Khan Academy does a little bit better than me. But probably every time they do it better than me, I shouldn't say sometimes. As you're going through the questions, though, you send me a message, right? Or we can post on the discussion board, say, hey, I got stuck on number 6, and maybe another student could jump on there and try to help out, give you clues, not answers, okay? Effort is key here, guys, effort. We don't have to get every single one right and be, math all-stars. I'd love that. But you just need to be trying, and when you have struggles, reach out, okay? Thanks, guys.